Let us continue studying continuity. Now, there are certain functions that in reality have to be continuous. Alright? Let me use a x and y axis here. No, let me put the y axis over here. So you might have a case where the temperature of water is at, say, 30 degrees Celsius, room temperature. You heat the water and it heats up and up and up, right? And it gets hotter and hotter. It reaches boiling point. You turn the stove off. It would cool slowly. Even if you drop some ice in the pot to make it cool faster, it will not jump down to a suddenly, instantly at another temperature. It will cool faster, right? And then it slows back down to 30. So changing temperature with respect to time is an inherently continuous function. You cannot get the temperature to drop from 50 to 49 degrees Celsius in zero time. Right? It will gradually drop over time, but not suddenly. So that is a continuous function. The temperature time function is continuous. Let's look at another function that is also continuous. Let me put back my graph here. I have erased part of my y-axis and erase my temperature. Another function that is inherently continuous deals with speed and time. You cannot change the speed of an object like the speed of a car suddenly, right? No matter how powerful the engine is, you're at 0 kilometers per hour, you accelerate. Even if you have a very strong and fast engine, as you try to accelerate from 0 to, say, 50 kilometers per hour, if you try too hard, the wheels will skid, right? So you go up to 50 kilometers. Even if it's able to do it in 3 seconds, very strong engine, it's still gradual. So let's say it goes to 0 to 50 kilometers in 3 seconds, right? And then you gradually go up to maybe 100 kilometers per hour. Even if you slam on the brakes, right, it will not jump to 0 in 0 seconds. It will gradually slow down. So speed, changing speed and time is another continuous function. It cannot change. Even if the car crashes into an object, this speed drops from whatever it is to 0 over a certain period of time. It's impossible to change the speed of any object like a car or even a small stone in 0 time. So that is a continuous function. Let's look at another. Let me erase my write things here. Alright, the growth of a tree. You may plant the tree when it is 6 inches high, tall, or when it is about 15 centimeters tall, and over time the height changes. These may be time in days or weeks. So the tree grows and grows, and over several days the tree gets taller. Alright, growth gradually slow down as it reaches a certain height. Now, the height of the tree is continuous between, say, 0 days, the time that you planted it, to, let's say, it takes 30 days for it to reach a certain height. You tell the gardener that you want it to reach that height. After 30 days it passes that height. The growth is continuous. There is no discontinuity there. After 45 days it has well passed the height that you wanted, and then the gardener comes and chops the tree. It suddenly, I should have my chopping at that point. It suddenly changed height. So even though you're talking about height in centimeters, depending on the situation, you can have a sudden change. The gardener chopped the tree and it suddenly changes height and leaves it, and it starts to grow again. Alright? Then the gardener visits sometime after, chop the tree again, and it jumps from here to here, and it starts growing again. Now you have a discontinuity. If the gardener chopped the tree at 45 days, then you have a discontinuity or a jump from, let's say it was 120 centimeters, and the gardener chops it down to 90 centimeters, because that's about the height that you want it. Alright, you have a discontinuity at that point when the gardener chopped the tree. Now even though measurement in centimeter is a continuous variable, right? The growth of the tree is continuous, but the chopping of the tree is sudden. It's discontinuous. It's not like speed, where you can cut the speed suddenly in 0 seconds or in a small fraction of a second, right? Well, even if it's a small fraction of a second, it's still gradual. But in this case, the height of the tree practically or theoretically, you can say it has changed in 0 seconds, right? So in this case, you have a discontinuity at this point. Now when you see a graph looking like this, it means there is a discontinuity there. Even if one or more of the circle is shaded, there is a discontinuity at that point. Alright? So you have a discontinuous function at that point, and it's a break in the value of the function at this point. Just like in the previous video, when we plotted the modulus of x divided by x, you had not only a discontinuity but a break in the values. If you remember The other function that we plotted in the previous videos, x squared minus 4 divided by x minus 2, there was no break from one value to another in the value of the function, but there was a discontinuity at x equal 2. Alright, so you have various functions that can be discontinuous. Now here we looked at the chopping of the tree by the gardener. Another one could be this. Let's look at another function that has discontinuity. Let's say you have a warehouse and you have a stock of items in the warehouse. You can have a situation like this. Alright, what happened in that case? You had a stock of 100 bags of cement in the warehouse at your hardware, right? Now you may have some outside of the warehouse that you're selling, but we're concentrating on inside the warehouse. Then customers from Monday, Tuesday and Wednesday, those stocks that are at the front, near to the front desk that you're selling, they're running low. So you open the warehouse, go inside and take out 30 bags. So you had a jump. No, you take out 30 bags. This would drop down to 70, of course. You suddenly had a change from 100 to 70. You drop down to 70. Thursday, Friday, it remained at 70 because you locked the door and you did not go in there for any more cement. Maybe you went in there for other things like lumber. Maybe you went in there for tin set or other things, but I'm concentrating on the stock of bags of cement in the warehouse. So you had a sudden change in the number of bags of cement inside the warehouse, right? It could be that a truck went inside there. Your men who work in the warehouse put on 30 bags. It drove out to be unloaded. So you had a sudden jump in the number of bags of cement inside the warehouse. So in this case, you have a discontinuity. It could also be the number of chairs inside an auditorium. It could be the number of anything. It could be people, number of people at a function, right? It could be the number of cars at a warehouse or a car lot to be rented or sold. Whatever it is, as long as you can have a sudden change, then in that case you have a discontinuity, right? Now I have an open circle and a shaded circle. In this case of the open circle, it could be a matter where you record the number of bags of cement in the warehouse. So on Monday you had 100, Tuesday you had 100, on Wednesday, just before the truck left, you had 100. but you recorded 70 because the truck left the warehouse with 30, so you now have 70 left, and you want to leave it on record that there are only 70 bags of cement in the warehouse, so that come Thursday you record the number of bags that are currently there. Alright, so in this case you have this discontinuity. So there are various functions in reality. Some of them are discontinuous, some of them are continuous, and those that are discontinuous may be continuous over a certain interval but discontinuous over another set of interval. Right? Monday, Tuesday to Wednesday morning, before the bags of cement were removed, the function was continuous, but there's a discontinuity at the time when the truck left with those bags. So you had a jump from 100 bags to 70 bags. Alright, so we'll continue with this topic in another video.